Hi, let's talk about the current status of spectrum analyzers and in general, professional lab equipment. What do you usually think when looking at professional equipment? That those devices are expensive and often unaffordable for hobbyists. In this video, I will try to give an overview of the current situation and how various activities can help transform the professional lab equipment so that an average hobbyist is able to work on more advanced projects. But before I go into more details, if you like my content, please give it a like and subscribe. Thanks. In the last videos, I did go through products that try to address the status quo of professional equipment. They are quite successful in commodizing scintillators, that is, devices that previously were reserved only to professionals or highly technical hobbyists. If you look at the reasons why this is happening, there are several causes for it. The demand is low and often related with government and military agencies that are not heavily money constrained. On the other side, if you look at some companies' history, like for example Rohde and Schwarz, you can see this history is heavily shaped by those agencies. Commercial R&D departments that use equipment for high frequency analysis often don't focus on money but quality of the hardware. Each manufacturer builds their own software that is delivered along with hardware. Due to complexity of a software and low competition, a given vendor may be the only on the market to provide a specific software function. Due to this situation of critically low supply, it's up to the manufacturer to set the price. Lab vendors often provide software packages that provide functionalities on top of a device, for example, additional protocol decoding, or even to enable wider hardware bandwidth on an oscilloscope from 300 MHz to 1 GHz. The natural first move to reduce costs is to introduce open source software for lab equipment. A good example of a successful software in this sphere is Scope Client that comes with a quite powerful set of functionalities that include not only advanced analysis of signals like doing an eye diagram, but also have various decoding functionalities. Functionalities for highly specialized hardware like 10 gigabits Ethernet packets analysis or PCIe data decoding is available for free and not as a software extension for thousands or even tens of thousands of dollars. This enables hobbyists to build complex projects for smaller amounts of money, at least in theory. I said at least in theory because software like Scope Client requires a specialized and trusted hardware able to acquire data at either speed and accuracy to properly presented collected data. Even though currently there is no commercial company that is providing only hardware for open source software, I think it's just a matter of time for this to start happening. Over the past decade, there have been moves to build open source scopes. Even back in 2010, possibly there were earlier attempts, but at that time, widely available components were not that well performant. Plus, a project in 2010 was an outcome of a bachelor thesis only. It takes years of development to build high-grade test equipment. Fortunately, it's now 2024 and we can see the move to reduce reliance on commercial vendors and build open source based scopes is now in place. Just recently, a project to sell a community built oscilloscope called Thunderscope is out. The project managed to set up a successful fund to build a supply chain and produce hardware that is fully compatible with Scope Client. We can also download source code of the board designs and if we are hardware or FPGA developers, contribute to the project. The project allows for up to 500 MHz bandwidth, which brings it much closer to the higher end of scopes, and it will be pretty much a scope of choice for hobbyists as it provides a good alternative to commercial products for less money. With time, commercial users may follow. Google Chrome is one of the most popular web browsers around the globe. It's based on the Chromium web browser that is actively developed by Google employees. Even though the browser is a leader in the market, which gives Google company competitive advantage, to ensure continuity of browser viability, R&D activities are happening all the time. Let's have a look at the four standards published by Google employees with a clear focus on Chrome OS on their site. We have Web Serial API, useful to connect devices that communicate via classical serial console manner. It's useful for low bandwidth communication, but the integration overhead is very low as the communication is a simple binary input-output stream with a fixed baud rate, that is, number of signal changes per second. As for now, this is only available in Chrome, Edge, and Opera browsers. WebUSB is a standard to provide USB connectivity directly to a web browser. This is more performant than serial connectivity, but the integration is slightly more complicated. Same as with the Web Serial API, this functionality is available in Chrome, Edge, and Opera browsers. Although WebUSB is technically the most performant solution, more optimization should be done in order to achieve fast connectivity to enable high-performance communication channels with devices. If any software wants to acquire data from, for example, scopes for processing in the browser, it would need not 1 megabyte per second, but 10 gigabytes per second bandwidth. I was only able to find one performance test where it was possible to achieve max USB controller speed of Raspberry Pi Pico. Are higher values possible? Who knows? Going in a slightly different direction, Chrome released Direct Sockets API with an intention to be working only with isolated contexts that put higher security constraints on a website, and a website itself only runs as a Chrome application. To stress, Firefox is against allowing web browsers to have such a direct access to peripherals. The stance is that almost all hardware designers did not consider the fact that their products could be managed by a web application, which can lead to a potential exploitation of hardware weaknesses. Is it overthinking or a real concern? Only time will tell. Google Chrome also was one of the adopters of WebAssembly, a standard established by Mozilla and Google. WebAssembly is especially important here as it can enable efficient processing of high amounts of data. WASM can support complex operations on GPU, which can be extremely important in future lab equipment design, especially as Thunderscope uses machine memory instead of its own to store samples, CPU for triggering, and GPU for displaying. Companies that create lab equipment invest a lot of money to build their products. They are often unique and require specialist equipment in the first place in order to produce their highly specialized products. Here, the situation isn't that bad. With cheap FPGA being more broadly available each year, we can see progress in having more powerful hobbyist equipment. Ham Radiosphere is here a good example with creative engineers building software-defined radios with wider receiving bandwidth that can always be modified to sweep across whole available spectrum. There are more powerful SDRs being designed and produced, with some being able to easily work as an oscilloscope, as they provide up to 650 MHz bandwidth, or be a 5G test equipment. It is a great news that can push 5G adoption forward not only among communication service providers but also among enterprises and hobbyists. So who is using those web standards in their product lines? Not many people and projects, to be honest. There have been a couple attempts in trying to build products with those technologies. As for now, only several small projects for lab equipment was done, like Nano VNA web app or a proof of concept tool to perform replay attacks with HackRF. In a previous video, I mentioned a case of Flipper Zero that uses WebUSB API in its web application to give a wider set of functionalities. Even though it's not a core technology used in the ecosystem, it makes it more comprehensive. Let's build a proof of concept of a spectrum analyzer software to provide features worth thousands of dollars for devices that cost much less. We can have a regular spectrum scanning, a waterfall, we can save analysis to a file for later processing, or we can also decode data for testing. As our input, we will use a budget spectrum analyzer that I have, TinySA Ultra, and we will also make a use of a Python script created by the author of TinySA to control the device via a serial connection. I will not go through details of the code implementation. You can see the code on my GitHub, link is in the description. When we open the application, we can select the desired spectrum to analyze, as well as the number of points to generate within the spectrum. Once we connect, we start seeing our asked spectrum, as well as there's a waterfall diagram being generated. We can also download CSV with a list of acquired data for later processing or documentation. Now let's say TinySA Ultra is able to provide enough data for any meaningful protocol to be decoded. A quick check on GitHub for a 433 keyword, which refers to a class of devices that use 433 MHz frequency to send commands, gives over 800 code projects. Not too bad. We can use code from those projects to incorporate into the proof of concept. Also, if we look at the traction of how many new JavaScript libraries are being created and added to NPM, we could state that in the future, all of the applications will be a web application. I hope you did learning something useful here, got a wider context and also how technology evolves in the direction of commoditization. As usual, this video is not sponsored by anyone. The statements made here are my personal opinions and I prefer to state like that. One more time, please like and subscribe and see you in the next video.